Yes, dear students. Now, in last video, I explained you graphical representation and general Newton formula for velocity of wheels. But our here chapter has aimed to explain sound, speed of sound, and other characteristics of sound also. So please take care. So Newton used Young's modulus. Young's modulus of elasticity. To find the speed of sound wave in solids. I told you general formula of Newton was V equal to under root E upon D. Generally, Newton derived the speed of sound depends on elasticity and density. And I have told you while taking the chapter of mechanical properties of solids that we measure elasticity in different ways. For solids, we measure it as Young's modulus as well as bulk modulus also. For liquid and gases, we measure bulk modulus. And in gases, I will tell you that actually bulk modulus B equal to minus delta P upon delta V into V के बराबर होता है ना? In gases, we can prove it is equal to pressure and so many things. So Newton used Young's modulus of velocity to find the speed of sound wave in solids in this formula. That is, and hence Newton's formula. Newton's formula for sound wave, for speed of sound wave, for speed of sound wave. Is given by V equal to under root E upon D. Oh, sorry यार दिमाग डिस्टर्ब हो गया. Given by V equal to under root capital Y upon D. Capital Y is the Young's modulus, you know. Y Young's modulus. And D density. In case of steel, Young's modulus, you know, for steel, Y equal to 2 into 10 power 11 Newton per meter square, and density D equal to nearly 8 into 10 power 3 kg per meter cube. So if we put this here, we get V equal to 2 into 10 power 11 upon 8 into 10 power 3. It is equal to under root 10 to power 8 upon 4. The square root come out to be 10 to power 4 upon 2 is equal to 5000 meter per second. This value of speed of sound in solids is obtained totally on theoretical idea. Practically, speed of sound wave was also measured and that was the same. This value, I should say, this theoretical value, this theoretical value of the speed of sound waves in solids, but in steel, I should say, agrees with experimental value. Experimental value. So we can say that Newton's theoretical formula is correct to find the speed of sound wave in solids, and hence Newton's formula is correct. Newton formula, I should say like this, Newton formula for finding the velocity of sound wave in solid. Newton formula for finding velocity of sound wave in solids is correct. So Newton formula to velocity of sound wave is the characteristic of elasticity and density, basically, not V equal to L lambda. Remember, in a solid, all wave of whatsoever frequency, whatsoever the wavelength, in a given material, the speed of sound will be the same, irrespective of frequency and wavelength. So V equal to N lambda, so if V fix है medium में, if V increases for a given frequency, wavelength will be according to that. It is not that if we increase frequency, the speed of sound will increase. On changing frequency, there is other characteristic of sound which is called pitch, that will change. The speed of sound will not change. Dear friend, I don't know how you like me. A year I was taking a practical exam of class 11. We had in our school that year 5 sections. And I asked a single question, two waves of wavelength, 1 meter and other one, lambda 1, lambda 2, 1.01 meter, travel through steel, which has a greater speed of, which is faster in solids. No one could answer. That was very surprising for me, and I was ashamed of what we have taught students. The speed of sound in medium is the characteristic of medium, not of the wavelength and frequency. Frequency, wavelength determine the other things. That is theoretical definition as well as practical. But remember that speed of whether it is sound wave or ultrasound or infrasound, in a medium all sounds have same velocity. Please learn it very carefully what I say. I said here that the speed of all sounds, whether ultrasound, infrasound or audible sound, 3 types of sound waves are there. By sound wave have frequency ranging from 20 Hz to 20 kHz. Ultrasound have frequency more than 20,000 Hz, but we can't listen them. Other animals can listen, but human being can receive or can detect or can listen the sound whose frequency vary from 20 hertz to 20 kilohertz. Again, less than 20 hertz are called infrasonic. We can't learn. So we cannot listen them. Animals, different animals have different ability. So this was about Newton's formula for velocity of sound in medium, and I took solid. Now, speed of sound in liquids. There are some simple things which always confuse us. So actually, this is not the mistake of learner. In the early, V equal to N lambda is taught. So we feel that velocity will depend on wavelength as well as frequency. But velocity of wave in a medium is the totally decided by elasticity and density of medium. So please be careful that in one medium all sound waves, whether ultrasound, infrasonic or audible sound, all have same speed in one medium. In different medium they have different speeds, but in one medium. Now Newton used bulk modulus. Bulk modulus of elasticity of liquids to find the speed of sound in solids. Hence, speed of sound in liquids is given by V equal to under root V upon D. V is bulk modulus. Of elasticity. D density. For water bulk modulus, I have shown you table. You keep on revise the table. There is table in the book. Here bulk modulus of water 2.2 into 10 to the power 9. I mean 2.2 gigapascal for water. V equal to 2.2 10 to the power 9. Nearly 100 times less than steel. And D equal to 1000 kg per meter cube. So speed of sound in water V equal to under root 2.2 10 to the power 9 upon 10 to the power 3. Ten to the power 6 and Q root is 10 to the power 3 into 2.2. Here again there is problem in finding the square root. And please don't get nervous. Recall and try to find out the decimal. I'm again spelling, though I keep on spelling, it is 2.2. Before decimal pair are made this way, here this way. 1 1 ya 1. 0.20. 2. 2 5 ya, nearly 2.25, 4 चलाते हैं, 4 डेसिमल दो प्लेट लेते हैं, 4 4 या 16, 4 2 या 8 और 1 9, 4 and 2. So now it is 8 and 2 and 2 0 further. We can go 8 times. 8 8 ja 64. It is 8 here. 8 8 ja 64, 8 ja 64, 6 68. 6 8 ja 16 or 6 22. So you can write it is 1.48 10 to the power 3 meter per second. This value of speed of sound in liquid agrees with experimental value. You can write yourself this thing. This value of speed of sound, which was derived, obtained from Newton's formula, is the same as that practical value of sound in solids. So Newton's formula for speed sound in solid or liquids was found correct. Now, the speed of sound in gases. While using this elasticity of gases, Newton thought that when sound wave travel through gases, temperature of gas does not change. Actually, gases have two elasticity. Isothermal elasticity and adiabatic. I have told you in details adiabatic process, isothermal process in detail. By isothermal change, gas law over Bayes law, PV equal to K. Using this thing, V delta P upon delta V into V, we can find it here equal to P. This thing is come out to be P. While doing adiabatic elasticity, so is the B adiabatic, वो गामा P होती है, गामा CP upon CP. So Newton suppose that when sound waves, you can write here, Newton used isothermal elasticity of gases to find speed of sound in gases. This is because according to Newton, when sound wave travel through gases. Newton himself proposed that when sound wave travel through gases, temperature of gas. So I am writing here when sound waves travel through gases, temperature of gases do not change. Isothermal elasticity of gases is equal to pressure P of the gas. And therefore, Newton's formula for velocity of sound wave in gases is given by V equal to under root P upon D. P is pressure of gas, which is equal to isothermal elasticity of gas. Newton used this formula to find the speed of sound in air at STP. At STP, P equal to 1.01 10 to the power 3 5 Newton per meter square, and density 1.3 kg per meter cube. If you put this value here, we get V equal to 280 meter per second. This value is very much less than the experimental value, which is 332 meter per second. At STP means at 0 degree centigrade and 1 atmospheric pressure. The speed of sound in gases is 332. It is 280 theoretically. So it means Newton formula is not found correct to find the value sound wave in gases. You can write it yourself. Newton formula is not correct to find the value sound wave in gases. He himself could not explain the discrepancy. In next video I will be telling who corrected this formula and why. Thank you.